Hello, everyone. Welcome to Science Buffs, the ultimate podcast for STEM enthusiasts. I'm Abby,
And I'm Sam.
and as you can tell by the title, we have a great episode for you, but Sam does not know the topic because I am presenting it today. But before we get into the STEM topic, Sam, how was your week or weekend?
It was good. I feel like the weekend went by so fast.
Yeah,
It was my mom's birthday, so we spent time with her and that was fun. And I like helped a friend move, so it's been busy, but
that's
yeah,
exciting.
I
It's
don't know.
also, we should note, it's like -6 degrees here or something, and it feels like
Yes.
-25 or in that
It's
range.
freezing here. Yeah,
It's
I
crazy.
should have gone out to shovel today and I did not leave my house.
Yeah, it's almost not worth it to go shovel.
Yeah.
Luckily, my husband went and shoveled, but he came in and I was like, well, that's your workout for the day. And he was like dripping, like when you're sweating but freezing
Oh,
cold, and he's like,
yes,
this
that's the
is
worst.
terrible. So yeah. But cool. Well, anything else this weekend? Anything
Um,
fun?
Nothing really. I started school back up, so been doing homework. So really nothing exciting at all.
That's
But I
fun.
got to see you, so that was fun.
Yes, we finally hung out, and all this talk of giving you your Christmas gift, and I forgot it. Oh. So we got to get coffee this week so I can actually give it to you. I
Yes,
did
I'm
tell
excited.
I did tell Sam what it was, so I will reveal to the podcast. It is a well, if anyone listens to the Toast podcast, they made this hoodie that looks like an NFL logo that says chili season. And that is what I got for Sam.
I'm
So
so excited.
yeah, I'm excited for you to have it and make it
I'm so
chilly.
excited. Yeah, I wanted one of those really bad, and then I was like, well, I'm not gonna buy it for myself. And then you got it for me,
And
so I'm
then
so
yeah,
excited.
you sent me the link and I was like, that's awesome. Click, 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 bye. I had it for so long.
Yes.
So
And I
good.
got you or I gave you your gift. I got you
Yes.
a actual like authentic matcha whisk
I
from
am
Japan.
so excited. I think I'm gonna make myself a matcha latte tomorrow and use the whisk. I'm very
Yes.
excited.
Yeah, so you're supposed to whisk it until you see bubbles. Like, and it's very
Okay.
vigorous. Don't be
Right.
afraid.
I've
Like
seen
they
people
were
like putting
showing
in
it.
some elbow grease.
Yeah. So
So
use
okay.
that. Yep.
I'm excited. It's so authentic.
Yes. So I was very excited about that. But
Good. Yeah. Well, it was fun to actually hang out. So we'll have to get coffee again this week,
yes,
which
we
is
will. I
great.
got to see your son and I was very excited because he's getting so big.
Yeah, he can sit in a high chair by himself now. And
Yeah, that's
I mean,
crazy.
yeah, it's wild. Like I sit him up now and I'm like, he's sitting on his
Well,
own.
I saw one time at brunch, he started like slumping down a little bit, and you had to go over and pick
He
him
just
up.
like I looked over and he was like eating his cracker, like just
Yeah, just kind of
lounging.
slumping down.
So
And
he's
then he
not
was
quite there
obsessed.
yet, but
Yeah, he was obsessed with the restroom sign.
oh my gosh, yeah, he could not get enough. I feel like I'm gonna have to buy one or make one.
Oh my gosh, I will give him anything he wants.
Yes, his
Always.
aunt will spoil him. So yeah, I tried to venture out of the house today I wanted to go to Target, and then I was like, well, it's a -6. I can't really take him out into the cold. So I was like, well, I'll just go into, like the drive-through of Starbucks because I like need to leave, but I can't really take him out of the house or, out of the car. My car was like struggling to get hot air
Oh
and
my
make it actually
goodness.
hot. I was like, am I just gonna have to turn around and like go
That's
back home
crazy.
empty-handed? So yeah, the cold, I'm kind of over the cold, but it's gonna be back to the 50s like this week. So
That's crazy. I know. I was kind of afraid because I needed to fill my car up the other day and I was worried that my gas tank like lid wouldn't come off cuz on my
oh
old
yeah.
car it wouldn't like if it would freeze over.
Yeah, I
But I
had
was
that
okay.
problem on I think it was an older car. But or actually it might have been my current car where it like freezes over and then I was like I had no gas and I couldn't open the tank. And I was like,
Yeah.
what is a girl to do?
We need
Luckily
to plan
now.
ahead better like
Although now
before it
I
gets
have a
cold.
garage. So,
That's
but this is
fair.
why my dad fills up at half. Like it hits half, he's filling up. I'm like going to like 100
You
miles left.
you and me are the same.
I do not let the light go on though, ever. That's
Oh,
my
I've only
rule.
let it go on a couple times and I was out of windshield wiper fluid and I've
Oh
never filled it
gosh.
up. My dad has always done it.
Oh,
So I had my dad show me how to do it.
I saw someone go, yeah, I'm like very responsible. I only like I fill up as soon as the light goes on. And I was like, huh? It's like I don't let it go much for past the light going on. I was like, that is not my definition of responsible.
No, like
So that'll be our
that's not
poll.
good.
When do you fill up your car?
Yeah,
At
because
half
if it gets below a certain point, can't it like freeze in your
and
tank?
like not have your car like you could run out of gas. I don't know.
You could literally just run out of gas. Yeah, that would
Because
make
my car
sense.
says like you have 100 miles left, and then it goes down slowly like normal, and then once it hits like 40, this only happened one time. Once it hits 40, it's automatically like zero. Like it was like 40, and then like 3 seconds later, 30,
Oh
20, and
my
then it
God.
shut off, and I like sputtered into a gas station. I was like, I thought I had 40 miles. So I'm scarred. But
Oh my
anyway,
goodness.
I am ready to get into the topic, if you will.
Yes, I can't wait. Give me my
Okay,
clues.
here are your clues.
Okay.
Okay, it is related to electronics.
FPGAs.
No, but I know almost nothing about FPGAs, so that'd be a great episode in the future.
I don't know why that was the first thing that came to mind.
That's very specific. Okay. It is shown in the movie Hidden Figures.
Oh my gosh. Is it the IBM machine?
Yeah, I mean you're very, very
IBM
close.
computer?
Kinda.
That would take up like the whole room.
Yeah, well, yeah, not quite, but you're on very, very hot.
Okay.
I mean, kind of, you got it. But my third clue is I think every person should learn how to write it. So,
Oh, coding?
yes,
Oh, just like general
just
coding.
general computer code.
Oh my gosh, I'm so excited to learn this from a software engineer.
Yes. So, because, okay, I was excited to dive into this because if you don't know, I have been a software engineer, like for the audience, I have been a software engineer since I graduated college, but I kind of like fell into it. I declared my minor as a software engineer, like computer science, and then I got hired as a software engineer before taking a single class like of software. So I just learned it kind of on the job. And so I didn't learn a lot of the best practices, I feel like. And, I don't know. So I was
I
excited to
feel
get a
like I
little bit more in
remember
depth.
I remember during your first internship when we were still in college, it was a software engineering internship and you were learning Python
Yes.
scripting. You were like, most of my time is spent just teaching myself Python.
Yeah, that's my biggest tip for anyone who wants to like get into engineering and especially software, like especially getting out of college, because for our whole class of aerospace engineers, like really we didn't learn a lot of code. We learned MATLAB, which is like scripting and very basic, and like you're not going to really get a software engineering job there, but I would just apply anyway because you just learn on the job, and you'll be fine. And Code Academy if you want to learn, but we'll talk about that later. Okay, so I looked up this website called computerscience.org, and it does a good job of explaining kind of what code is and what it's used for and how it works. So we're going to go through this article. So it says electronic devices like phones, laptops, tablets require code to function properly. And basically, the gist of it is that code allows humans to communicate with devices. So all modern technology really has code. They mention things like traffic lights, calculators, smart TVs, cars. They all have like an internal coding system so that humans can interact with the devices and tell them what to do. So coding basically acts as the translator. Obviously, a machine doesn't know how we are communicating with it, so it needs code to like be that middleman between us and the binary language on the computer. It says code converts human input into numerical sequences that computers can understand. And then once computers receive those messages, it will know to go complete a task. So if you, like in a very simple algorithm, you can say like, if this condition is met, so like, let's say if the user inputs the letter A, then go and turn on this LED light. That's an example of something that you can code. And so the code and the compiler act to actually tell the computer that like once this condition is met, go do this action.
What's a compiler?
I'm going to get there. So
Yay,
hold that
okay.
question. Okay. So how does coding work? Very basic. Computer programming languages are developed through a series of numerical or alphabetic codes. And again, they instruct machines to complete specific tasks. And the computer coding functions much like a manual for the computer. So the programmer writes instructions, and then computers scan extensive coded manuals, it says, very quickly, executes the tasks, and creates a successful like website, application, any one of those devices that have code. It says displaying an image or section of text, changing font styles, opening emails, all require instructions in the coded manual. So let's see. Okay, types of programming languages. Let's get into this because basically this article just goes into a lot of depth. And so it's just saying like, yes, it translates what humans are trying to say. So binary code is comprised of just zeros and ones. So that's what I was kind of mentioning, that everything at the very base level is just zeros and ones. And that is what's used to communicate the instructions. So it's very, very low level. And like a lot of humans, like I never learned how to code in binary, so all these languages and layers on top are just making it easier for humans to read it. Each digit in a coded sequence connects to a switch in your computer. So this is what I've never really understood at the very low level, is that all of those binary numbers, each one of those is a switch in your computer. Each switch connects to an action, and together thousands of switches operate a device.
What? These
So
must be so small.
yes, I think they are, yeah, extremely small. So that's low level code. High level code is a communication process that works more like human language. So like you mentioned, Python is one of the higher level codes. So you're writing in the English language, or, I'm sure you could code in another language, but for us, you're just writing in an English language saying like, if user input equals A, so you can easily go through the code and read it as a human being. You're not just reading ones and zeros. High level programming languages convert human language for programmers into binary code that computers understand. So what the compiler does is like you're writing the code, the compiler will then convert it into the language that the computer will actually understand. So it goes from like the high level language to the low level language that will actually control the switches.
So high level is that like the closer it is to the computer's
Yes.
language, basically. So, because I've heard like C or C++ is a low level language, right? Which means it's not quite as easily understood by like just reading it in the English language.
Yes. Yeah. So yeah, high level is like more human readable, low level is like assembly language is like you're actually just typing in the physical instructions that the code will do like after the compiler step. So just really quick, just the definition of a compiler. It says a compiler supports the source programming language, reads the files, analyzes the code, and translates it into a format suitable for the target platform. So like in C++ or some of these languages, you'll write a script and then you'll try to compile it. Now, if there's an error, it's not going to compile. So that's a good way to check if your code is good, like a good first check to see if all your syntax is right and stuff like that, because it all needs to be pretty specific given each language that you're working in. So the compiler kind of also acts for you at like a little bit of a debugger, just at a high level to say, hey, there's something really wrong with your code. But then assuming it's all correct, it will then analyze it, translate it into that binary, and be ready for execution. So it kind of packages it up for you. Okay, So sorry, I lost
So
my spot here. Yeah, go ahead.
what's the advantage? So I've always wondered like why would you use a low level code? And I've been told like a low level language, and
Hmm.
I've been told because you have more control over the
Yeah,
output. Is that correct?
yeah, like some high level languages will have like internal compilers that handle things a certain way, and maybe it's less efficient, but it's like, cleaner or something, and or it's less risky, but it takes a lot more, it's less efficient. So you can, by choosing a low level language, you can kind of bypass that and do it however you want. And so some people like to do that, especially, if you have a very kind of niche uh task that you need to do, or like you need to save CPU, or you know it might be good to use a lower level language. So yeah, like you said, you have more control over how it all compiles. So as you may imagine, different languages can be used for different goals. So for like websites, you would use something like HTML, CSS, or JavaScript code to create like websites and layouts and designs. Um, it says websites with like Facebook, Instagram, LinkedIn, which require user accounts, connect to like SQL, Java, Python, and then like cell phones, computer software, they can use things like C Sharp, Swift, Ruby, Rails, Python. So some of them are definitely more adaptable to different goals or end products, but yeah, so you choose the language based on your own comfort, how much control you want, but also like what you're actually trying to make with this piece of code. And I'll link this website because it has a really good breakdown of like I mean, not every language, but all the big languages and kind of what they are geared for, or what they're best to be used for. And then this gives some like fun, or I guess practical tips about learning how to code. Um, it says it might be difficult for some, but it can also be rewarding. So there's like coding boot camps. There's obviously you can get like a coding degree. There are massive open online courses, they're called. And you can also do self-guided, and it mentions things like Code Academy, where you can just sign up for an account there and it'll walk you through a class of like the basics of any coding language pretty much. So I learned a ton from Code Academy, which um, is just, it's like the best website ever. It like saved me in my internship.
That's amazing. Did you primarily use it for Python?
Yes, I use it for Python and C++. So, and it has like different versions of them. So like as it was kind of interesting, like Python, um, they had like this old version and then they had a big update, and a lot of the syntax actually changed, and you can choose like which one you want to go learn,
That's
because
awesome.
my program used the old one, of course. So I was like, I learning the new one doesn't help as much. So yeah, that website is really, really good. And also, I was going to talk about this at the end, but I guess we'll just talk about it now. My like, if you think that you're not into math or like not STEM minded or whatever, my computer science teacher told me that the best computer science student he had ever taught was a creative writing and English major, because it kind of is the same, like you're crafting and like structuring this piece of code kind of like you would a paper. And so there tends to be a good crossover between if you can write well and if you can write code well. So I thought that
That
was
makes
interesting
sense.
because I never would have put those together. Like I thought, oh, I'm, not great at English. And I do find like I feel like I'm not that great at writing articles or papers or anything. And so it is harder for me a little bit, I think, to like structure how I want my code to be laid out. Like I tend to just vomit all the code there and then try to like reorganize later. And so it like, don't be discouraged if you are a good writer, you can also code. And even if you're not a good writer, you'll be fine. So, okay. Then the next one that I wanted, or the next thing I wanted to talk about is just a brief history of code and coding languages and stuff, because I watched Hidden Figures, and like her having the foresight. What was her name? That one. It wasn't Catherine. I'll have to look up her name. But one of the women in Hidden Figures saw that the IBM machine moved in, And she's like, oh, they said it can do your job in like a fraction of a second. But she's like, well, someone has to program it. So I'm going to teach all of the girls who work under me to program it. And she had the foresight, and like her women had jobs once the IBM was up and running. So that
Ugh,
made
I
me
need
want
to
to look
go
into the
rewatch this
history.
movie.
Oh, I watched it last night. It is so good. It's like my favorite
I love
movie
this
ever.
movie. Yes.
And I was
If
turning
you
to
haven't
Jason
seen
like every
Hidden
2 seconds.
Figures,
I was like, this is my favorite scene. And I was like, wait, this is my favorite scene.
yeah, if you haven't seen Hidden Figures, you need to go watch it. It's about African American women that contributed greatly to the space race.
Yes.
And it's a fantastic movie.
So good.
Probably my
So
favorite movie, by the
I
way.
think it's like in my top three for sure. It's so good. Okay. Quick timeline of code. So 1883, the first programming language was developed in 1883 when Ada Lovelace and Charles Babbage worked together on what's called the analytical engine. So it was basically a primitive mechanical computer. So it says Lovelace was able to discern the importance of numbers, realizing that they could represent more than just numerical values of things. She wrote an algorithm for the analytical engine, the first computer program to compute Bernoulli numbers. Bernie.
Bernoulli, yes.
Bernoulli. So
What year was that?
1883.
I remember learning about Ada Lovelace, but if you had
Yes.
asked me her name and said what did she do, I probably wouldn't have remembered.
Yes. And the first like computer programming language is named after her, and it's Ada. And I think possibly you were in the class where we had to translate Ada into MATLAB code
Yes,
in
or
college.
yeah, there was another super old language that we had to also translate
Fortran.
into MATLAB. Fortran, yes,
Yeah.
into MATLAB
Yeah.
code.
And in Hidden Figures, she checks out a Fortran book from the library. So,
That's right.
um, so yeah, okay. So then nothing, I mean, probably something happens in between there, but there's like a big gap in this timeline. So the next uh entry is in 1949. So like 70 years later or something. Assembly language was first used as a type of computer programming language that was able to simplify machine code language, which is necessary for telling a computer what to do. So before 1949, if they wrote code, they were writing it in the like binary machine language. So assembly language was then created to have like one step above. Now I think of assembly language as like basically the lowest level. Like that, I don't know. You're like talking to specific registers in your computer, and it's very, very involved. So
That sounds
I'm glad I
extremely
didn't want to be a
complicated.
software engineer in 1949.
Yeah,
Uh,
seriously.
okay, 1952, Alec Glennie developed AutoCode, which some consider to be the first compiled computer programming language, which means it could be translated directly into machine code. 1957, John Backus created Fortran. So it's a computer programming language for working with scientific, mathematical, and statistical projects. So I guess like to revisit the thing where we had to translate into Fortran, I guess the thought behind that was that a lot of these companies that we would possibly work for one day have like such old like machines and code and stuff that we need to be able to read Fortran, which I've not had to do in my
I have.
professional career. You have,
Yeah,
really?
I've worked in my professional career with Fortran very briefly, but
Was that
yeah,
in
it
your
still
last
exists.
program?
It still
Yeah.
exists.
Okay,
So
yes. So I guess they taught us well.
yeah, and it's
um
important to use that like critical thinking skill, I feel like, to understand, like, because even if you're not programming something in one language, it's important to be able to kind of at least understand or read
yeah,
code as an engineer.
yeah,
So
yes, very good point. And I feel like once you kind of have a handle on one language, that's why I don't think it's that important to have a specific first language that you know. Like once you have a grasp on one, you kind of can just pick up the other ones. It's all just a matter of like syntax and Googling, in this language, how do I do an if then loop or if else loop or whatever. So, um,
yeah,
Okay, 1958, ALGOL, it's called, was created as an algorithmic language. It was also a precursor to programming languages like Java and C. So we're getting there. COBOL was created by Dr. Grace Murray Harper in 1959, the next year, to be a language that could operate on all types of computers. So everything is just getting a little bit more advanced. Also in the 1959, there is a programming language called Lisp, which is apparently still used today. A man named John McCarthy created Lisp. So it was designed for use in artificial intelligence research. But today it can be used like in conjunction with Python and Ruby. Sorry, Ruby. My bad. Okay, 1964, BASIC is a new programming language that came on, or that was developed. Pascal was developed in 1970. I'm just going to speed through these because, you know. Smalltalk, 1972. Okay,
I haven't heard of that one.
I haven't either. 1972, Dennis Ritchie developed C, generally regarded as the first high-level programming language. This means it's closer to human language and less like machine code. So C is actually a high level.
Well,
Is that what you
maybe it
said?
was, well, high level for that time, right? And then maybe low level now?
I
Because you would
think
think relatively it would adjust,
I
right?
think
Based off of.
C is considered lower than, like, I don't know if it's considered. Let me just look. Is C considered?
So you think the low versus high level would be relative based off of the other
Oh yeah,
options, you know?
yeah. C, you're right. So at the time it was high. Now C and C++ are now considered low-level languages because they have no automatic memory management. The definition of low level has changed quite a bit since the inception of computer science, and today we would not qualify C as a lower high level language, but rather more like an intermediary language.
Interesting. That's
So
cool. I didn't know
yeah,
that.
that is interesting that it changes like that. Okay, MATLAB, our favorite. I
Our
love
favorite.
MATLAB. That was in 1978.
Yeah, I'm sure you love
I
MATLAB.
actually do. Like, I really
I
get
do like
nostalgic
MATLAB.
with MATLAB. Like, I just really want to code something in MATLAB.
So the reason Abby's saying that is because all of our aerospace projects and basically everything we did for 4 years was in MATLAB.
Yes.
So yeah, the
Yes.
Matrix Laboratory. That's what it
Oh
stands for.
gosh. Oh, I don't know that. I didn't know that. I knew it was
Because you
Matrix
do a lot of
something.
Matrix math.
Yeah, Matrix totally makes sense. Okay, Perl, which is used for text editing and report processing, was 1987. I'm just gonna go through Python was developed in 1991. Visual Basic 1991. So I'm not gonna go through the rest of these, but there's more
Is R on
languages.
there? R is the only other one that I've really done. R is used for statistical analysis.
Ruby. Oh yeah, R 1993.
Oh, predates me.
For statisticians who needed to perform data analysis.
I found
So
it to be
yes.
very similar to MATLAB. I feel like I didn't have a good enough understanding of what their difference was because they seemed pretty much the exact same to me.
Yeah, some of these are pretty similar, but yeah, so that's the basic history. Basically, there's just a lot more languages that are always being developed, and it just aims to simplify the work for programmers. So the big trend is over the course of the years, it used to all be super low level, and then we've gradually gotten, it's become so much easier for us to code and to learn coding. So that should be encouraging. It'll get easier all the time, but if anyone wants to learn, again, you definitely should. So, okay, now this is a podcast about women in STEM, pretty much. I mean, not just, but it's run by two women in STEM. So I wanted to highlight some important women who contributed to coding history, basically.
I'm so excited for this section.
Yes. So the first one is Ada Lovelace. So this goes into a little bit more depth. She was born in 1815, which is much earlier than I thought, in London. So that puts her at basically 100 years before the first prototype of the modern day computer. But she's still regarded as a pioneer in programming because of her work on the analytical engine. So basically this says that she interpreted it was she okay, it says Ada's reputation can be attributed to her work on the interpretation of Charles Babbage's analytical engine. So it enabled the mechanization or the mechanizing of mathematical operations and is hence considered a major event in the timeline of computer evolution, as we saw in my timeline. So it says the Ada programming language is named after her. It's an object-oriented high-level programming language that has built-in support for design by contract, strong typing, concurrency, offering tasks. So there's like all these different features in the Ada program, but that was named after her because that is crazy to me that she is considered like this pioneer and she didn't even know what a computer was. Like there was no computer and there wouldn't be for 100 years. So very, very impressive. The next one is Grace Hopper. So she was born in 1906 and died in 1992. And I was thinking like, oh, she just died in 1992, but that's actually like over 30 years ago now. It seems
That's
it
crazy
seems not that long
to think
ago.
about.
But she was a computer scientist born in New York in 1906. She served in the US Navy, was like a big part of her life. And she had a ton of technological contributions, but the biggest one was the invention of the first compiler. So she invented it says the invention of the first compiler for a programming language and the pioneer ship in the programming of the Harvard Mark I computer. So she was the mind behind the machine independent programming languages, which later paved the way for COBOL, which is one of the ones on the timeline, which was basically the first high level programming language. So she was a big pioneer in that. Is crazy. She thought to invent a compiler. Like that's wild.
That is so cool. Grace Hopper, I'm pretty sure. I remember our friend from college that I went to go see in New York. She went to a Grace Hopper convention, which I think is specifically for women in software engineering. I'm like 90% sure. I'll look it up though, but I'm pretty
she's
sure
like one of the she's always on one of the big lists of like it's Ada Lovelace, Grace Hopper. So this is actually a group of programmers, but they're called the ENIAC programmers. I think it's called ENIAC. So it was 6 women programmers that created the first programmable computer that was fully electronic. So their names were, wow, this one has like a long name. Kathleen McNulty Mauchly Antonelli, Jean Jennings Bardick, Frances Snyder Holder, Marlin Westcoff Meltzer, Frances Bylas Spence, and Ruth Lichterman Teitelbaum.
You did your best.
Thank you. Thank you, everyone. So anyway, there was a project run by the U.S. Army, and it kind of gives like Code Girls vibes, where it was a secret World War II project. There weren't any programming languages then, and it had to be done based off of these logic diagrams. So they developed this program basically where it says the outcome of their efforts was a computer performing complex calculus in seconds. It says they also didn't receive due credit for their work, and they were later called the 6 Great Women of ENIAC. So yeah, kind of an undercover sort of thing. Edith Clark, another one. She was born in 1883. These are like very, very early programmers, which is interesting. But she was the first female electrical engineer.
What?
Yes.
That is so cool.
She was also the first female professor of electrical engineering at the University of Texas at Austin.
Wow.
It says she taught at a private school before joining that school. Let's see, when she worked there. Yeah, she managed to complete her degree in electrical engineering from Columbia University. She later became the first woman to enroll and earn a master's degree in electrical engineering, and she went to MIT. So very impressive. Amazing. Her most famous contribution is the Clark calculator that solved equations involving hyperbolic functions 10 times faster than other devices at the time. So
it's probably like a billion times faster than I would do it.
Yeah. This is
I couldn't solve that.
That is so impressive. I can't even imagine like coming up with something new like that, like inventing You have to be
I don't
so
have enough time to
smart
think, I don't
to
think.
know
Yeah.
that. I don't know. They're just very, very smart. Okay, Evelyn Boyd Granville, 1924. She was born, and apparently she is still alive as of the publishing of this website. She does not
Wow.
have a death date listed, but she was the second African American woman to earn a PhD in mathematics from an American university. She started her career with a teaching position at Fisk University. Then she joined the U.S. Space Technology Laboratories. So her big contribution was she helped with U.S. space missions by studying rocket trajectories and orbit computations.
That is so cool.
And she
Hidden
was,
Figures vibes.
yes, for sure. And it said she continued like advocating for women's education and in tech for her entire career.
Amazing.
Okay, this one is interesting. Sister Mary Kenneth Keller. So she was a nun. Among the first people in the US to receive a doctorate, Keller was a pioneer in computer science. It says after earning her master's in mathematics from DePaul University, she worked at the National Science Foundation, where she developed the programming language BASIC to make
Oh,
computer education more accessible to the masses. It says after her doctorate, she set up the computer science department at Clark College to promote computer education. And you look at a picture of her, and she's like in her full nun outfit, and she was
that's
like
amazing.
coding, and I'm like, that is awesome. Okay, Carol Shaw was born in 1955. She is the first female video game designer.
Oh,
So,
that's so cool.
yeah, she graduated with electrical engineering from UC Berkeley. So that's very cool. She created a lot of popular games for Atari Incorporated, like Polo 3D, 3D Tic Tac Toe, and River Raid. If you're familiar with any of those, but
Wow.
um, Janice Swanson was an American software developer. She founded Girl Tech, which is a company that made that is their goal is to make technology more interesting to women. So they kind of highlight a founder in here, which I think was cool. Also, she is a computer engineer, but she also founded a company to kind of spread the message. Radia Perlman, 1958, she was born. She invented the spanning tree protocol, which was fundamental to the operation of the internet. So she like
Wow.
laid the groundwork to the internet. And she also studied at MIT. She also developed a child-friendly robotic language called Tortoise,
I
which
love that.
stands for Toddler's Own Recursive Turtle Interpreter System. So yeah, like network design was her thing, link state protocols. She's the inventor of Trill, which is a different software that just like expands on this spanning tree concept. So she holds over 100 issued patents.
That's amazing. All of these women are so much smarter than me.
I know, they're so awesome. And then the last one on this list is Parisa Tabriz. I think I'm pronouncing that okay. But she has a passion for cybersecurity because she had a website and it got hacked. So she worked extensively on like network security and privacy enhancing technology like during her graduation. And it says she was soon selected for a summer internship at Google that later turned into a full-time role. She now leads internet security for Google Chrome worldwide. So the
Wow.
head of internet security. Basically, she just got into it because she's like, that sucks. My website got hacked. I want to learn about this so it doesn't happen again. And that like spiraled her into a passion for cybersecurity.
That's incredible.
Yeah. So yeah, I didn't know about like I only knew about the first two. So I'm glad
Yeah, same.
these articles exist that kind of compile it all together and we can learn about more because it's just so impressive like what they did. So anyway, that is all for my my research. Do you have any questions
That
or
was a great
anything I
topic.
missed?
You covered a lot. I don't have any questions. But
Good.
what is your favorite part or what was your favorite part about being a software engineer?
The feeling of when it works is like the biggest high like you can have, I think.
Yeah.
Like after it's not working for a long time, like as a backstory to the listeners, Sam and I had to do this lab in college called the Bottle Rocket Lab. and we had to like
Ugh.
calculate the trajectories of these bottle rockets, and like it was very complex. And I remember like working on this for weeks and weeks and weeks, and like it was so frustrating. And then all of a sudden, we got it and it worked. I don't
Yep.
think there's ever been a better feeling. Like I swear, when it like compiles and it works, and you find, especially when it's like it should all work and it's not working, and you can't find out why, and then
Yep.
all of a sudden you find it and it does work. It's just
It's the best feeling.
Yeah.
Yeah, I remember that too.
And you know,
And it
always
sounds not
happens.
complicated, but it is, because we had to take into account wind
Oh, it was.
and
I had
things like
I
that.
had scripts and scripts and scripts, like so many MATLAB modules open that were all tied together in these
Mhm.
crazy ways, and it was like, where in this mess is your problem? And I don't
Yep.
know, because like then we would plot graphs, and it's supposed to look like a launch,
Yep.
and mine would be like,
Yeah, it would like launch into
what?
space mid trajectory.
Yes, and I would always like have that epiphany where it worked if I just went and took a shower and then came back. Like if I
Yeah, or
ran
go
a
exercise.
go
That's what
exercise
me
or take a
too.
nap. Like you have to just be out of it for like 2 hours and then come back, and you like get it all the time, like immediately.
Yep.
And you think it won't work the next time, but it always works.
That's the best advice, probably, is if it's not working, walk away.
Yes. Yeah, exactly. So well, yeah, that's my episode. Thanks for listening, everyone. Thanks for listening, Sam. If you have not subscribed to the podcast and you are listening to it, please hit subscribe. That would be fantastic. And if you could also go and leave us a review, we would appreciate that greatly. Unless it's lower than a 5 stars, just give us 5-star reviews.
Please.
Please, please. And spread the word. Like if you have a woman or man in STEM that loves STEM, send them the podcast, Can't hurt. We would
Yes.
appreciate it. Anyway, we will be back with another episode next Wednesday, and we will see you then. That is all. See you
Thanks,
next week.
everyone.
Bye, everyone.
Bye.